darker than paint, hotter than lava. Meet TrES-2b. The universe is a vast expanse filled with brilliant lights. Stars burn with unimaginable fury. Galaxies swirl like great cosmic whirlpools of fire. Even planets, which produce no light of their own, often shine brightly, reflecting the radiance of their parent suns. Think of Venus, a dazzling point of light in our evening sky. We expect worlds to reflect light. It is how we see them. But out there, in the deep cosmic ocean, there is a world that breaks this rule. It is a planet so profoundly dark, it seems to defy the very nature of light. We call this enigmatic giant TrES-2b, the darkest planet ever discovered. The story of TrES-2b begins not with a flash of light, but with its absence. A profound darkness where there should be light. The planet was first detected in 2006 by the Transatlantic Exoplanet Survey, TrES. This wasn't a single giant observatory, but a clever network of small, automated scopes. These humble 10-centimetre telescopes were workhorses, staring relentlessly at vast patches of the night sky from different corners of the globe. Their mission was simple but monumental: to patiently watch hundreds of thousands of stars all at once. They looked for stars that blinked, a telltale sign known as the transit method. When a planet crosses in front of its star from our point of view, the star's brightness drops by a minuscule, almost imperceptible amount. And in a field of stars 750 light-years away, in the constellation Draco, they found one. The Sun-like star, GSC 03549-02811, was dimming. TrES saw a regular dip, a 1.5% drop in brightness, repeating every 2.5 days like clockwork. This suggested a world in an incredibly tight, fast orbit. The candidate was a hot Jupiter. But a transit alone isn't proof. Follow-up observations were crucial. Astronomers used the radial velocity method, measuring the star's wobble caused by the planet's gravitational tug. This confirmed the object's mass, revealing a gas giant with Jupiter-like size, but orbiting far closer to its star than Mercury does to our Sun. The discovery was confirmed. A new world was added to our catalogues. But its true strangeness would only surface years later, with more advanced observations from space by the Kepler telescope. We had found a shadow, deeper and darker than anyone had ever seen before. NASA's Kepler Space Telescope unveiled the true nature of TrES-2b. Kepler stared at one patch of sky for years, monitoring over 150,000 stars. Dozens of transits produced an exquisitely detailed light curve. Astronomers also watched the planet pass behind the star, the secondary eclipse. Subtracting the before and after reveals the planet's reflected light. In 2011, researchers found almost no reflected light. The dip was fantastically small. Geometric albedo. A perfect mirror is 1, a perfect absorber is 0. Earth reflects about 0.3, even the Moon reflects around 12%. TrES-2b's albedo is under 0.01, darker than black acrylic paint, as dark as fresh asphalt. It appears to trap its star's light. A featureless black sphere, giving almost nothing back. The profound darkness of TrES-2b begs the question, why? What forces conspire to create a world that absorbs over 99% of the light that falls upon it, making it darker than a lump of coal? The answer lies in its extreme and hostile atmosphere. Unlike Jupiter, which is wrapped in bright reflective ammonia clouds, this hot Jupiter is blisteringly cloudless. Its proximity to its star creates an environment of unimaginable heat, fundamentally altering its atmospheric chemistry and preventing any familiar cloud layers from forming. Its dayside exceeds 1,000 degrees Celsius, a temperature hot enough to melt lead and even iron. At this furnace-like temperature, substances we know as cloud formers, ammonia, water, would vaporize instantly. There's simply no cool upper layer in the atmosphere where they could condense. Without bright cloud decks to reflect starlight back into space, the gases themselves set the planet's appearance. And the gases present in TrES-2b's atmosphere are exceptionally good at swallowing light. Astronomers theorize that vaporized sodium and potassium and gaseous titanium oxide permeate the atmosphere. These exotic materials are incredibly efficient at absorbing visible light across the spectrum. They act like a dark dye mixed into the upper atmosphere, trapping incoming photons before they have a chance to scatter away. This process is so effective, it leaves almost no light to be reflected. Another possibility is that the extreme heat may sustain a perpetual haze, like a planet-wide layer of soot. The intense stellar radiation could break down complex carbon-based molecules, a process called photolysis, leaving a dense, dark smog of light-absorbing hydrocarbons high in the air. The most plausible picture combines these ideas. A searingly hot, cloudless sky laced with a potent cocktail of light-absorbing chemical compounds. But this profound darkness only refers to visible light. At these temperatures, the planet itself glows. It radiates heat, emitting its own faint light in the infrared part of the spectrum. So, while it appears as a black void to our eyes, it shines with a dull, deep red heat, like dying embers in a fire or a hot electric stove element glowing menacingly in the dark. Let us imagine for a moment an impossible journey to TrES-2b. Our vessel, a craft built only in thought, must cross over 750 light-years of interstellar void to reach this enigmatic world. From afar, it appears as a hole in space, a perfect circle of night. It doesn't just block the light from its star, it actively swallows it, reflecting almost nothing back into the cosmos. It is a true phantom, a sphere of absolute blackness against the tapestry of the Milky Way. As we draw closer, its brilliant star, a yellow sun, much like our own, floods our view with fierce, unfiltered light. The glare is blinding, forcing our senses to their limits, yet the planet stays stubbornly dark. No oceans, no white clouds, no continents. There are no familiar patterns, no swirls of weather, just an unnerving, uniform void. It is a world stripped of all recognizable features. Only a menacing, dull, cherry-red rim betrays its heat on the day side. This is not reflected light, but the planet's own incandescent fury, a thermal signature glowing at over 1,000 degrees Celsius. Plunging into its upper atmosphere, the sky would be a thick, dark shroud, tinged with its own thermal glow. The light-absorbing chemicals, perhaps vaporized sodium and potassium, create a perpetual suffocating twilight. Pressure surges relentlessly, compressing our imaginary ship. Temperatures climb high enough to melt lead, then iron. Even rock itself would turn to liquid here. Winds, driven by the day-night extremes of a tidally locked world, likely scream at thousands of kilometers per hour. These are not mere gales, but planet-spanning shockwaves of superheated gas. There is no ground to land on, only a fall through ever hotter, ever darker layers of gas that grow denser than stone. The distinction between atmosphere and planet dissolves into a crushing, searing continuum. Eventually, the immense pressure would crush any ship to a speck, its atoms torn apart and absorbed, becoming one with the dark forever. A planet darker than coal is no mere curiosity. It sharpens our science. Measuring under 1% reflectivity across quadrillions of kilometers is a triumph of technology. It hints at a population of dark worlds best found by their shadows, not their light. It captures our imagination. Science fact that feels like science fiction. From a faint flicker to a world of heat-trapping chemistry, TrES-2b reshapes our expectations. We build instruments, point them skyward, and listen for the faintest signals. In the great dark between the stars, even shadows have stories to tell. Did TrES-2b surprise you? Did you like this video? Don't forget to like, subscribe, and share.